Bonjour à tous.
Good morning, everyone. Before talking about PAMs, we're going to talk about MAPs in other agricultural sectors. In 2018, we had already started working on it. First, for breeding, new breeding techniques with mastitis treatments based on essential oils, for instance. So the first works were targeting this kind of production. Now it's more the vegetable productions and plant productions that's coming to us to know how they could use our maps in their production system. Why? Because of the wide range of botanic species we have, and in terms of phytochemicals expertise, we need to explain where the results come from. And the associative plants can be interesting for nitrogen, to fight against pests, and biogracers to attract pollinators. And of course, MAPs are not interesting for every aspect, for soil fertilization, for instance, but the main reason is fighting bioaggressors and pollination, and sometimes also for weed management, especially in arboriculture and wine growing. So, a few words on how to fight against weeds. The PLACOB project and Cocosol, supported by the Pays de la Loire Agricultural Chamber. The idea was to work with vine growing, horticulture, and fruit growing. So these main sectors were looking into us, and to use plants to cover their soil to replace phytosanitary treatments based on synthetic chemicals like Roundup to avoid weeds. So the idea was to replace these chemicals by vegetable covers. And some of those covers tested were Achillea millifolia, Calendula officinalis, peppermint, melilot, mouse ear hawkweed, etc. But we really focused on Achillea millifolia, Calendula, and mouse ear hawkweed. So we stopped the trial 3 years ago, and to date, arboricultural fields that had been covered with Achillea millifolia have less weed and are still covered with the Achillea. Mouse ear hawkweed is doing very well in horticultural cultivation. Like they do replace weed very well. In terms of managing bioaggressors, it's a bit more difficult. We are partners to several projects like Alto, Repulse, Abapic. Institutes like INRAE or ACTA are working with us. So MAPs actually have an interest as service plants. They have various interactions with their environment. They can welcome biodiversity, they can attract auxiliaries, they can repel some bioaggressors like aphids or cicadells, for instance. And all these interactions between MAPs and their environment goes through the chemical systems of the plant. And plants emit molecules that are disseminated in the atmosphere. So that's what we call volatile organic compounds, VOC. And this topic has been focused on in other plant sectors for the past 3-4 years, given that some other phytochemical solutions were banned. So those VOC, some volatile molecules, have shown a repellent effect on insects, for instance. So results can be mitigated or complex to really synthesize or to understand. For the Abapic project, it's an accelerator of biocontrol. It's a cross-sector project with all plant productions, macroorganisms, biocontrol products, and they have a chapter on VOCs. At first, we were only one of the many partners, and then, thanks to Denis, we became leader of this working group because we realized that not everyone would understand clearly what VOC was and what the analysis techniques were like. And so we had a lot of different techniques that had been used, and the results were hard to interpret. So other sectors read or heard from experts that one plant was interesting, so they just bought it, like a ribwort or something. They test it, and sometimes the results are what they are. But for example, with thyme, they bought one type of thyme, like thymol, and it was the other one, the linalool, that was supposed to work. So, but they didn't know anything about that. So we need to have an expert choosing the right plant to really, go further just basic publications in the choice of maps. And also what stage of growth the map is when you're using it against pest, because it's not always the same organ in the plant that will have the same properties. Some are useful for the flowers, some for the leaves, etc. Also, the emission conditions of these VOCs, because the weather, of course, has an impact. If you have drier weather or wetter weather, the wind, the emission in the atmosphere, if it's very windy, are going to be sent away. So results can then be difficult to interpret if you don't take that into account. So ideas that are going to be tested, yes, if you plant rosemary or thyme, maybe if you just shake them with a mechanical bar or something, you can actually shake the VOCs, and that could be interesting. It's been tested with rosemary and arboriculture, and it seems to work pretty fine. And then you need the analytical aspect and how to capture VOCs. What tools can we use to capture them, and then how to analyze them. A lot of analyses were only qualitative. We knew that such or such molecule was present in the atmosphere, but we had no quantitative notion, no concentration notion. Therefore, this is what we've started doing in the Abapic project to try and standardize the methodology, whether for capture or analysis of VOCs. Among these various projects, what really strikes is the methodological aspect. So we're going to have a follow-up that's going to be designed this winter or in spring on the VOC aspect of biocontrol to really come up with a methodological method that's going to be used the same way in all sectors so that the results can be comparable and used. And it also opens the door to new ideas to use plant extracts with disseminators, dissemination in the field of these extracts. So maybe we need to find a way to granulate or to put in capsule these extracts and to still follow up, of course, these VOC emissions. We've tried that with some different extracts, especially in horticulture. So we need to see, to test if this or that molecule is more interesting and in which quantity. Another interesting aspect in maps is regarding biodiversity. It's really connected to the previous part of the sessions. We're talking about repelling pests, but they can also promote the presence of some auxiliary like rosemary in our arboriculture. In the lab, we knew it worked. Some rosemary really could repel aphids. We tested that in the field. Results were more mitigated, less positive, because VOCs was invisible, of course, but some results were interesting on aphids. Some analyses were carried out more accurately on biodiversity, especially regarding auxiliaries in the microparcels where there was rosemary, and we found many more auxiliaries, especially arachnids. So the question is, it's better with rosemary. Is it better because of VOCs? Is it because it attracts biodiversity? It's probably a mix. It's probably VOCs plus attraction of the auxiliaries. So it's connected to the push-pull theory, which we're using a lot in vegetable growing, because these service plants can be used to attract pests outside of the field by planting them further away from the field. It can be tried with maps. Once again, we keep having the same analytical methodology issues, so we need to take that into account. Last but not least, we have a lot of honey-promoting plants, and we need to attract pollinators for longer periods of time. So it's a bonus. Like we haven't studied these effects on honey plants from honey plants a lot, but it's being studied these days. To conclude, there are still many things to look into. We're starting to have good ideas on, especially for VOCs. A lot of methodological work has been carried out already, a lot of improvement. Capturing and analyzing VOCs has started being standardized so that we can really understand the phenomenon at stake. And we're also developing the extract dissemination. Some private companies that we've been in contact with are interested in what we're working on in that regard and the skills we're developing. Something I haven't mentioned, although it was written, one of the reasons why other sectors are looking into maps, of course, the iteipmai's expertise is useful, but many of them think that they can actually grow and promote and sell their own maps, so it would be an interest crop, if you will. On paper, it looks nice, but there are many issues raised. From seed to harvest, it's not that easy to implement. You need specific equipment that vine growers, for instance, do not have. And another issue is the phytosanitary homologation aspect, because on the same plot, you need products to be authorized for both cultures, both crops. And it's not possible today in conventional and very complicated in organic growing. So it's a hindrance. Not forgetting the market aspect. If every wine grower was starting to produce thyme, it would overflow the market. Now, I thank you for your attention.